Good morning to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? Very good morning to all of you. I think we are live. So first of all, do check करके बोलिए now is the audio video is clear to all of you? Right. The first thing what I want to say here. So these are the ESC 2025 ranks from Unacademy. You can enjoy these things, see these things. This is now it's time for you. You can start your serious preparation with an academy to achieve your dream goals. So these are the see this thing. These many rankers are there, many more. And from gate 2027 2028 के लिए हमने नया टेस्ट सीरीज भी शुरू किया. You can see this thing. And the new batches we are starting from 2027 के लिए and 2028 के लिए भी नया बैच हमने लॉन्च किया. You can enroll for it. You can use the code of BV Reddy and to get the personalized discount and personalized guidance from me. Right. These are the West Bengal Electricity Department का course we have launched. You can have a look at now. These many courses are running, crash course, Nakshatra batch, and another great features you can see that is Unacademy Una. With this, there are three different modes are there. One is a voice mode, quiz mode, smart summaries. With the three modes you can utilize, you can able to get the maximum benefit from this, especially from the smart summaries will help you a lot. Before going to the exam, it will summarize all the content. It will prepare your short notes, will prepare itself only. You no need to prepare your short notes. And the test series is live, and we are offering the two subscriptions. One is a plus wala, other one is iconic. And iconic में additional features क्या मिलेगा? So here personal coach मिलेगा as well as physical notes भी आपको मिलेगा. Right. We can start your serious preparation an academy to achieve your dream goals. Right. 2025 rankers from an academy का. Right. चलिए आज का सेशन हम शुरू करेगा. And the last class we have discussed about the some of the basic electromagnetic wave equations हमने शुरू किया. So dispersion concept हमने analyze किया, basics. Right. Now let's continue our discussions. Phase velocity हमने discuss किया, group velocity भी हमने discuss किया, and concept of dispersion भी हमने analyze किया. Right. Yeah, try this problem. A 1 megahertz plane wave traveling in a normally dispersive lossless medium has a phase velocity at this frequency given as this much. The phase velocity as a function of wavelength is given as like this. Now they asking to find what, tell me now here. Find the group velocity. Now they asking to find the group velocity. They given the phase velocity given as Vp value, which is not a constant, which is a variable quantity, and this is changing with the time. Sorry, with the wavelength it is changing. So this value Vp, which is given as k into root of lambda, right? So we need to do so analyze it now here. As the wavelength changing means frequency also changing, right? So let's find the relation between the variation of group velocity with the wavelength also. Now, the relation between the group velocity, phase velocity and wavelength, which is equal to what, tell me now, that is Vg, which is equal to Vp minus lambda into dVp by d lambda, the variation of the phase velocity. The phase velocity changes with respect to lambda. So this is the relations. And so we need to get the Vg value. So Vp we have, will differentiate the Vp. Vp given as what element here, k into root lambda. So then it is dVp by d lambda, which is equal to what element of k into root x derivative 1 by 2 root x na, 1 by 2 root lambda. So that is given as k by 2 into root lambda, right? Now, and we can replace now here. So then Vg, which is equal to Vp, and Vp value given now how much it is, a 3 into 10 power 8. So 3 into 10 power 8 minus lambda into dVp by d lambda, which is equal to k by 2 into root lambda, right? And we need to get this lambda. How we can get this lambda? You see here, if you simplify, Vg will come to be a 3 into 10 power 8 minus 1 by 2 into 1 by 2 k also into root lambda, right? And here you need to get the value of k value also, we need to get k value and lambda also. So let's see this thing, how we can get this k value and lambda value. And frequency given how much it is, 1 mega, and then phase velocity given this much. From this we can get the lambda value. How much, you tell me now? Lambda, which is equal to V by F. V value how much now? 3 into 10 power 8 by frequency is 10 power 6. Will come to be a what, tell me now? 3 into 10 square. And if I place this at this particular frequency, velocity is a 3 into 10 power 8, and which is equal to k into lambda value, that is, so 3 into 10 square. So we'll come it as what, tell me now, k value from this. We can get the k value from this now here. How much will come here? This is 3 into 10 power 8 by, this is root 3 into 10. So we'll get this k value. How much now? This is root 3 into 10 power 7. You can substitute these values here. Now Vg, which is equal to what, tell me? 3 into 10 power 8 minus k value. This is root 3 by 2. Root 3 by 2 into 10 power 7, and root lambda which is equal to, that is root 3 into 10. So we'll come it as Vg equal to how much now? 3 into 10 power 8 minus root 3 into root 3 is a 3 now here, that is 3 by 2 into 10 power 8. So you can tell me how much will come. So that is 3 by 2 into 10 power 8 meters per second. This is the group velocity. Done. Next, yeah, intrinsic impedance. Intrinsic impedance means what? The impedance offered by the medium for the propagation of electromagnetic waves is called as an intrinsic medium. The intrinsic impedance. The impedance offered by the medium offered by the medium for the propagation of electromagnetic waves. Electromagnetic waves is called intrinsic impedance. Right? Now, if I consider the wave is propagating along the z directions, then what are the parameters you can find? You see this thing. So the electric field, it should be in the form of what direction? Which will contains only the x component and y components only, Ex and as well as y component only. It does not have any along the component along z direction. Why? Because we are assuming that wave is propagating along the z directions. The electromagnetic wave which propagates along the z direction. So K, which we have taken as z directions. And magnetic field expression. Magnetic field also does not contain any other component along the z direction. So that is Hx into Ax plus what tell me now here? Hy into Ay. Right. The impedance, that is intrinsic impedance, which is given as intrinsic impedance eta, and which is given as what we can see now here, magnet E by H, which is called as a intrinsic impedance, E by H, and this E by H, and this is given as, this is square root of j omega mu by sigma plus j omega epsilon, sigma plus j omega epsilon. This is the intrinsic impedance. And what are the units are? Ohms. The units are ohms. Right? Next, propagation constant. Propagation constant. Propagation constant, so that is called as a gamma. So we have the electric field expression basically, which is equal to E, which is of the form E naught into e power minus gamma z we have, where this gamma, which is called as a propagation constant. Gamma is called as a propagation constant. And this gamma, which is given as alpha plus j beta. gamma, which is given as alpha plus j beta, where this alpha is alpha, which is called as a attenuation constant. Alpha is called as a attenuation constant. Attenuation constant alpha, which is given as, that is given by real part of gamma. Real part of gamma is alpha, and yes, this gamma also we can write, that is gamma, which is given as square root of j omega mu into sigma plus j omega epsilon, and beta, which is the phase constant. Beta, which is a phase constant beta, and which is given as, that is imaginary part of gamma is a beta. Beta is a phase constant, that is imaginary part of beta. Gamma is called as a phase constant. Right? Now if we observe here, this eta we have seen now, where this gamma, which is equal to, that is alpha plus j beta, and that is given as what? Square root of j omega mu into sigma plus j omega epsilon, and then gamma, and then eta we have. Eta, which is given as what, tell me? Square root of j omega mu by sigma plus j omega epsilon. Right. If we multiply these two here, so what will get to, tell me now? Gamma into eta, if we multiply, denominator term will get cancelled, will come it as j omega mu will come. And if we have taken the ratio now here, this is gamma by eta, we have taken ratio, then it will come it as sigma plus j omega epsilon. Sigma plus j omega epsilon. Right? Next. Now let us talk about this as a propagation of electromagnetic waves through different type of medium. Different type of mediums we'll talk now here. The first we are talking about the free space. Right. The propagation of the waves through any medium will depends upon its medium parameters. And what the medium parameters for the free space is a, for the free space, mu is given as mu naught, epsilon is given as epsilon naught, and sigma is given as a 0. Sigma given as a 0. Mu is mu naught, epsilon is epsilon naught, sigma value 0. And then we can see this as a gamma, and that is given as alpha plus j beta. Gamma is alpha plus j beta, and which is equal to square root of j omega mu into sigma plus j omega epsilon. J omega mu into sigma plus j omega epsilon. Right. So here let us substitute the values in this case now. Then alpha plus j beta, which is equal to square root of j omega mu is what, tell me now? Mu naught, and sigma value 0 plus this is j omega epsilon is epsilon naught. then we'll come it as alpha plus j beta, which is equal to what I will get now here, j omega into square root of mu naught epsilon naught. From this alpha value how much? 0. Beta value how much? That is omega square root of mu naught epsilon naught. This is beta. So if we observe here alpha equal to 0 means what? Tell me. Attenuation constant is 0. Attenuation constant is 0 means what? The electromagnetic wave does not have any attenuation for its propagation. As we have seen E electric field expression, which is equal to what? Tell me. E naught into e power minus alpha z into cos of omega t minus beta z into what? Tell me now. Ex cap. And this term, the amplitude, which is given as what? Tell me now. The magnitude of electric field or amplitude of electric field magnitude of electric field is given by what? Tell me. So that is given as E is equal to what? Tell me now. This magnitude is E naught into e power minus of alpha z. How much is alpha value here? 0. If alpha value 0, how much this magnitude will become? You tell me now, which is equal to 0 only. The magnitude of electric field is how much? 0. That means is it is an advantage or disadvantage? It is one of the greatest advantage. So that means, so here, even though the electromagnetic waves will travel any distance, so along the z direction, you can see now here, the amplitude remains constant only. Now tell me. The amplitude remains constant forever. So this, how much this amplitude is? E naught only. Is it is an advantage now? So the amplitude remains constant forever. Okay. Now, and what else we have seen now? Omega we have seen. How much is omega value? So how much is beta value in terms of omega? We can write beta, which is equal to what? Tell me now. Omega into square root of mu naught epsilon naught. So omega into square root of mu naught epsilon naught. So from this we can get the Vp. What is the Vp? Is the phase velocity, which is given as what? Tell me now. Omega by beta, and which is equal to what? Tell me now. Omega by beta, that is omega into square root of, that is mu naught epsilon naught. From this Vp will come to be a what? Tell me. 1 by square root of mu naught epsilon naught. This is the phase velocity. And if we substitute the mu naught value, epsilon naught value, then Vp value will come to be how much? 3 into 10 power 8 meters per second. So from this we can conclude this as what? Tell me. In free space, the electromagnetic waves will travel with a velocity equal to velocity of light. Right. Next, and let's find the Vg also. And what is the relation between the Vp and Vg? The groove velocity, which is equal to phase velocity Vp by 1 minus beta into dVp by d omega. dVp by d omega. If we see here Vp value, which is a constant value, how much it is? A 3 into 10 power 8. It is a constant if I differentiate the Vp with respect to omega. Yeah, you tell me what happens now here will become 0. It will becomes what tell me now 0, right? So now what I'll get this Vg value now. So that is Vp by that is 1 minus beta, this term is 0 na. So in this case what we got, you see this thing here, Vg equal to Vp, that is what we can say na, group velocity and phase velocities both are equal, right? Phase velocity, group velocities are equal in case of a free space only. And another important thing you need to remember, if we multiply the Vp and Vg, you can see, so that is Vp into Vg, which will come to be what tell me now, c square. What is c? Is the velocity of light. Vp into Vg, which is equal to what tell me, c square. And we'll find the intrinsic impedance also. Intrinsic impedance is eta, which is given as what tell me, E by H, and that equal to what tell me, that is formula, that is square root of j omega mu by sigma plus j omega epsilon. So you can see this thing here, eta value that equal to E by H. Now if we substitute the values now here, it will become square root of mu naught by epsilon naught will come na, sigma value 0 na for the free space. We know the mu naught value, epsilon naught value, by substituting them you will get this value of eta will come to be how much, 120 pi. Eta value come to be how much, 120 pi. That means what we can say here, the free space will offers an impedance of 120 pi for the propagation of electromagnetic waves. The free space will offer how much the impedance, 120 pi. And the impedance, which is nature, is what nature? Purely resistive nature. Resistive nature of impedance na, right? Next, now let us talk about the propagation through ideal dielectrics. Ideal dielectrics means what, tell me? In case of ideal dielectrics, here mu dielectrics, that is mu r into mu naught, and epsilon is what, tell me? Epsilon r into epsilon naught, and sigma value how much, 0. Sigma value 0. Again same thing we will proceed. Yes, the propagation constant gamma, which is given as what, tell me? Alpha plus j beta, and that equal to, yeah, square root of j omega mu into what, tell me now, sigma plus j omega epsilon. If I substitute the terms, that is alpha plus j beta, this will come to be a square root of j omega, that is mu r into mu naught, into this is j omega epsilon r into epsilon naught, then alpha plus j beta, which will come to be a j omega into, we can write it as square root of mu r epsilon r into square root of mu naught epsilon naught. I am simply separating the two roots are separated for simply remember, easy to remember. Now by comparison, alpha is a real part na. Real part is 0. And we have the imaginary part is how much? That is omega square root of, that is mu r epsilon r into square root of mu naught epsilon naught. Okay. Then again in this case also you can observe here alpha value 0. Alpha 0 means there is no loss of electric field. No electric field loss, no magnetic field will loss. That means the electromagnetic waves does not experience any loss of energy. Without any loss, the electromagnetic waves can propagate now. So that's why what we can write now here, the electromagnetic waves can propagate to the ideal dielectrics without any loss of energy. That's why this ideal dielectrics, which we used to call it as a lossless medium, which will be called as a lossless medium. Ideal dielectrics are called as what, you tell me? Lossless medium. Okay. Now, so in this case, you tell me now whatever the phase velocity Vp equal to what, tell me now, omega by beta. So that is what we can say now, omega by beta. That is what, tell me now, square root of mu r into epsilon r into square root of mu naught epsilon naught. So then this will come to be a what, tell me now here? That is 1 by square root of omega is, where is omega? Omega also. So this omega will get cancelled. So we'll come it as what, tell me now here? That is mu naught epsilon naught into what, tell me now here? 1 by square root of mu r epsilon r. So that is Vp will come to be a this value 3 into 10 power 8 by square root of mu r epsilon r, that is meters per second. That is meters per second. Okay. So you tell me now where the velocity is high, you tell me now. In the free space is higher, lossless medium is high. In free space, velocity is 3 into 10 power 8. Lossless medium denominator we have something. So that's why here the Vp, which is less than 3 into 10 power 8. Right. And we can find the terms now here. What now here? The other terms we can find. We use another term that is called as a refractive index. What is the refractive index means? What, tell me? Refractive index. Refractive index of a medium, that is denoted as n, and which is given as, this is the ratio between velocity, free space velocity we can write simply, velocity in free space velocity by velocity in a medium. Velocity in a medium. So that is n is equal to free space velocity is how much? 3 into 10 power 8, and velocity in a medium is how much? 3 into 10 power 8 by square root of mu r epsilon r. That equal to square root of mu r epsilon r will come. This is the refractive index of a medium. Most of the cases mu r is 1, so we can use this as epsilon r only, root of. Next, let's find the group velocity. And what about the group velocity? You can see, and the relation between the phase velocity and group velocity, Vg is equal to what? Tell me now. Vp by 1 minus beta into what? Tell me now. dVp by d omega. As Vp value constant, how much is Vp value? That is 3 into 10 power 8 by, that is square root of, and mu r epsilon r. So what is the dVp by d omega? You tell me now. dVp by d omega, which is equal to 0. So then if it is 0, then what I will get the Vg value? Tell me. So that means Vg, which is equal to Vp only. That is group velocity and phase velocities both are equal. Next. And what about the intrinsic impedance? You tell me now. The intrinsic impedance eta, which is given as E by H. Yeah, that equal to what? Tell me now. Square root of j omega mu by sigma plus j omega epsilon. Right. Now you can tell me now here, if we substitute the terms now here, that is E by H, and which is equal to square root of j omega mu is mu r into mu naught, sigma 0, that is j omega epsilon r into epsilon naught. That is E equal to what? Tell me now. E by H, which is equal to, this is square root of what we have? Tell me now. This is mu naught by epsilon naught into, this is square root of mu r by epsilon r. So this eta, this is E by H, and which is equal, this value is a 120 pi into square root of what? Tell me, mu r by epsilon r. This is ohms. So the intrinsic impedance is 120 pi into square root of mu r by epsilon r. Okay. This is the lossless medium. Yeah, take this problem. The electric field of a plane wave propagating through the free space is given by like this. Now they are asking to find the terms now. Direction of propagation of wave. Yeah, first bit you tell me now here. And what's the direction of propagation of wave? Tell me. Direction of propagation of wave. That is what tell me now here? Negative x directions. Yes or no, tell me. That is negative x directions. Next one. Frequency of the wave. Tell me. Frequency of wave. Frequency. We need to find the frequency of the wave. So for this, what we should do here, the medium is given as what element of free space. In free space, what the velocity is 3 into 10 power 8. So the Vp value, how much now? 3 into 10 power 8 meters per second. And so then they given the beta value, we know now how much is beta value, which is equal to 4. So that means we have the relation Vp equal to what, tell me now? Omega by beta. Then omega equal to what we can say now here? Vp into beta banega. So that means omega Vp value is what, tell me now? 3 into 10 power 8 into beta value, how much now? 4. So how much is omega value now here? This is 12 into 10 power 8 radians per second. This is radians per second. If I want the in the options you see this thing units, either radians per second चाहिए या hertz में चाहिए तो अगर if the hertz में चाहिए तो then f is equal to what we can say now here 12 by 2 pi into 10 power 8. Now then this is in hertz में होगा. Okay. And wavelength. Wavelength is what, tell me? Yes, wavelength lambda. Lambda, which is given as what, tell me now? 2 pi by beta. Lambda 2 pi by beta. So this lambda value, which will come to be how much now? That is 2 pi by 4. This value come to be a pi by 2. That means how much now? 1.59 meters. And thereafter we need to calculate what, tell me? The corresponding magnetic field we should find. Yeah, look at now what we can do here. They given the electric field is given now. So we need to find the corresponding magnetic field. How much is electric field, you tell me now? That E value, which is given as what, tell me now? 25 into that is sine of omega t plus 4x into what, tell me now? Ay cap. How we can get this amplitude magnetic field now here? So this magnetic field H which could be equal to, and we can see the relation now here, E by H is equal to eta. E by H is equal to what, tell me now? Eta. So we can find this thing here. H is equal to what we can say now? E by eta will come to be what, tell me now here? 25 by eta na, and the medium is given as free space, so that is 120 pi into sine of what I will get to, tell me now? Omega t plus 4x. And what else you can see now here? And by using the orthogonal property we can get the direction. Electric field, magnetic field, and direction of propagation of wave are orthogonal, orthonormal, and follows right-handed system, right? So we need which direction now here? H direction we need. For this, what I should do? Tell me now. K cross E we do. What we'll do? K cross E. So tell me now. K cross E is a K cross E will give the H direction. H direction is given as K cross E. K is what, tell me now here? This is minus AX cross electric field is what direction, tell me now here? AY cap. So then H value which is given as what we can say now here, 25 by 120 pi into what, tell me now here, sine of omega t plus 4x into what, tell me now here, minus into what will get now here, AZ cap now. So finally we got this as a magnetic field expressions, and the direction of magnetic field is along the negative Z directions. Okay, got it? So this finding the E to H is one of the important things. Now take the next problem. If the electric field intensity of a uniform plane wave in air is given as like this, they are asking to find the what will be the magnetic field expressions. So the electric field E, which is given as what element, 20 into e power minus j5z into ax cap minus 25 into e power minus j5z into ay cap. So we need to find the magnetic field we should find. So this is H value, and which is equal to H value, which will be equal to, yes, now E by H. So first we can find the amplitude now here. E magnitude by eta. Medium is a air given na air medium. So that is impedance is how much now? 120 pi. And this term is same only now, minus j5z, and we need the direction. And what's the direction of what, tell me now, magnetic field? How we get the direction of magnetic field, you tell me now? That is K cross E. What will get, you tell me now? K cross E. K is what, tell me now here? This is AZ cross what, tell me now? E. That is what, tell me now? AX minus what is this thing? 25 by 120 pi into e power minus j5z into what, tell me now here? K cross E. K is what, tell me now here? This is AZ cross what, tell me now? AY. Yeah, simplify and get it. Then H value come to be a, so this is 20 by 120 pi into e power minus j5z and AZ cross AX. So this is AX, AY, AZ. So this AZ cross AX means positive only na. This is plus AY cap minus 25 by 120 pi into e power minus j5z into AZ cross AY. Reverse we are moving now. We'll get minus. This minus minus will become plus. Plus AX will come. Okay. Right. So then simplify. Check this thing. Option B. Next one. So an electric wave propagating through a lossless medium, they given mu naught 81 epsilon naught is given by the phase constant they ask him to find. Now phase constant here, omega value, how much is value? 6 pi into 10 power 8. Beta value we don't know, and then we can find the Vp, which is equal to omega by beta, and that is also equal to 3 into 10 power 8 by, that is square root of mu naught epsilon naught. How much is omega value? 6 pi into 10 power 8 by beta, which is equal to 3 into 10 power 8. So this is mu r epsilon r, sorry. This is mu r epsilon r. Mu r epsilon r, that is mu r value 1, epsilon r value 81. So how much this value? So check for cancellations now here. So this value will get cancelled, 3 2's now. Now will come to be a 2 pi. 2 pi by beta, which is equal to 1 by 9, right? Then beta equal to how much now here? 18 pi. So that is radians per meters. Option C. Next, the electric field vector of a EM wave in free space is given as like this. They ask him to find the what will be the magnetic field they ask him to find. The medium is a free space, right? Yeah, so you can find the magnetic field now here. So this is H value, which is equal to A by, so this is eta into what I can say now, this is cos of omega. This whole term, let us call this as something x मान लीजिए. We can say this as x. And direction is ay cap na. And what will get this is, now this is wave is along the z direction, az cross ay. So how much will come, you tell me now here? That is a by eta, which is, we can say this is mu naught epsilon naught into this is cos omega x into this is a minus ax cap. Okay, az cross ay na, that is minus ax. So we'll get this as magnetic field. How much we got now here? This is square root of, so that is epsilon naught by mu naught into a into this is cos of omega x into minus ax cap. यहाँ तक clear ना? Then तो what's the option, you tell me now? Option तो नहीं है ना? So हमने कुछ करना पड़ेगा. Here they given the j terms are given, so we should make it as j terms. So what I will do here now. So as we know here, j means how much now here? Pi by 2. As you might be know, j means how much this angle is a pi by 2. J square equal to minus 1 na. So we try to modify it now. So j square, which is equal to minus 1, this means angle is how much? 180. J means pi by 2. J square means pi. So what I am doing is, so this value and this thing, I am writing it as, So minus 1 means pi. So I am keeping this as j into j. Okay, j square is j into j. And this is square root of epsilon naught by mu naught into a into this is cos of omega x into ax. Is it fine? 1j taken to phase angle, that is j square root of epsilon naught by mu naught into a into cos of omega x. 1j means pi by 2 into ax cap. Then h is equal to what? Tell me now here. J into square root of epsilon naught by mu naught a into cos pi by 2 plus theta, which is equal to minus sign. So again minus will come here. Minus sign of omega x. X is equal to what we now? T minus z by c na into ax cap. Now you see these options now. कौन सा option? Option D. चेक करके बोलिए. बहुत बहुत बढ़िया प्रॉब्लम. See this problem and tell me if you have a doubt. A very good problem. Next one. The electric field of a plane wave propagating through the free space is given. Find its magnetic field expression. The electric field expression, which is given as what? Tell me now here. 25 into sine of omega t minus 4x plus 3z into ay cap. Now they ask you to find the magnetic field. So first of all, so we need to see the direction of propagation of wave, and here it is an oblique propagation here. That is sine of omega t minus common. Then it will come to be a what element of 4x minus 3z into what element of here ay cap. Yes, here the wave is propagating. What we can say now, direction of wave propagation, I can say k cap. What we can say now, 4 into x is there now, so it is ax minus 3 into what element of az by this magnitude, which is equal to 5. This is the direction of propagation of wave. It is an oblique propagation. Then remaining thing is normal. So what is a magnetic field expression, you tell me now? So medium is a free space only. Okay. So this is 25 by 120 into sine of, tell me now here, omega t minus 4x plus 3z into what? Tell me now, how will get the direction of magnetic field? K cross E. How will get now? K cross E. K is what? Tell me now here, 4ax minus 3az by 5k cross E is what tell me now? Y directions. Okay. Now we'll simplify it. So from this we can get this magnetic field expression as, so that is 25 by 120 into sine of, what tell me now here, omega t minus 4x plus 3z, and into what we have, tell me now here, this is 4 by 5 ax cross ay, which is equal to az, minus 3 by 5 into az cross ay, that is minus ax cap. This, and we'll have a magnetic field is along x direction as well as z direction also. Okay. Next one, conductors versus dielectrics. And so here basically the materials has been classified into two categories. One is conductors, the other one is dielectrics. So this we have this one of the Maxwell's equation, that is del cross H, which is equal to what, tell me now here, JC plus what, tell me now here, JD, where JC, which is called it as a conduction current density, that is given as what, tell me now, sigma E, and which is called it as what, tell me, this is called it as a conduction. This is called it as a conduction current density. Conduction current density, JC is called as. Next, other one JD, and which is equal to dou D by dou T. Dou D by dou T, and this is called it as a displacement current density. And this is called it as a displacement current density. JC is called as a conduction current density. JD is called as a displacement current density. Right. And the displacement current density JD, and that is given as, we can say, time harmonic form J omega epsilon into E. So we have taken the ratio between these two. We are taking the ratio between these two, JC and JD. Right. So that is what I'll be now here, JC by JD. We have taken a ratio between these two, that is JC by JD. This magnitude ratio we have taken as like this. JC and JD ratio we have taken. So that is JC, this ratio magnitude is what I'll be now here, that is sigma E. And JD, this magnitude is what I'll be now, that is omega epsilon E. So if you see, this thing will come to be what, tell me now, sigma by omega epsilon. Sigma by omega epsilon. Based upon this term sigma by omega epsilon, the materials has been classified. Right. So JC by JD, that is sigma by omega epsilon. So here, if JC by JD. If JC by JD, if it is very much greater than 1, that means what I'll be now? Sigma by omega epsilon. Sigma by omega epsilon, if it is very much greater than 1, very much greater than 1, that means what? Tell me now. We can call those materials are called as a good conductors. We'll call them as what? Tell me, good conductors. We are calling them as good conductors. Sigma by omega epsilon is very much greater. And if JC by JD, if it is less than 1, yes, that means what? Tell me now. Sigma by omega epsilon, if it is less than 1, then we can call them as a good dielectrics. We are call them as a good dielectrics. Right. And if JC by JD, if it is equal to 1, that means what? I'll be now sigma by omega epsilon, which is equal to 1, then we can call them as a semiconductors or the quasi-conductors. We are calling them as a quasi-conductors. So that means what happens now here? The material properties are not fixed. The material properties are depends upon the what we can say frequency of operation. Agar if we increase the frequency, if the omega value increases, the one which is very good conductor also, I can make them as a behave like a dielectrics. Okay, if I increase my frequency, the one which is very good conductor even will convert into a dielectric also. Based upon the selection of frequency, it will change. Just nature of material will change. Right. So, and so if you keep on increasing the frequency, the one which is very good conductor, that will be converted to a dielectric and the quasi conductors also. Now, and if you are changing the keep on, so the frequency at certain frequency, conduction current equal to displacement current, right? That frequency which we will call it as a transition frequency. The frequency at which conduction current is equal to displacement current. Displacement current is called transition frequency. The transition frequency will denote as EFT, which is equal to sigma by 2 pi epsilon. This is the transition frequency. At this frequency, the nature of a material changes from conductor to dielectric, equal to dielectric at this frequency. So it is just a dividing line. So if the frequency is less than, if we draw a frequency line here, if I call this a dividing line, so this frequency, if I say ft, so here at this location, for a frequency, if it is less than ft, the nature is good conductor. Nature is good conductor. And this is, if it is greater than ft, the nature is good electric. Then this nature is good electrics. Okay. Now, and if we have seen the phasor diagram, that is JC, which is equal to what else now, sigma E, and this JD, which is equal to J omega epsilon E, JE. So, and we can see the things now. Now, we draw this now phasor diagram for these two, and here this is JC and this is JD. So sigma E and this is J omega epsilon E. Now the resultant of these two, it should be equal to like this. The resultant of these two, it should be like this. And this is the total J. This is the total J, the resultant of this thing, which is like this. If we call this angle with the displacement current, this angle, if I call this as a theta. Now you tell me now tan theta is a, tan theta, which is given as what, tell me now, JC by JD. Tan theta equal to JC by JD. So that is given as tan theta. JC, that is given as sigma by omega epsilon. Sigma by omega epsilon. Where is tan theta? So based upon the sigma by omega epsilon, we are talking about the nature of material. If the sigma by omega epsilon is high, that is a good conductor. If it is good conductor, losses are more. Losses are more. And if it is sigma by omega epsilon is low, losses are less. So that's why we are naming it as a one special name, that is called as a loss tangent. Sigma by omega epsilon, which we used to call it as what, tell me? That is called as a loss tangent. Loss tangent. Sigma by omega epsilon, which is also called as a dissipation factor. Dissipation factor. Loss tangent are the dissipation factor. Okay. Now based upon the sigma by omega epsilon, we can comment about the natures. So means, and here you can see now, if the sigma by omega epsilon if sigma by omega epsilon is 0, then what is sigma value? Tell me now. Sigma value 0. Sigma value 0 means that is a dielectric. Then we can call that as what medium? Lossless medium. We'll call it as what medium? Lossless medium. Lossless medium. Next, if sigma by omega epsilon, if it is not equal to 0, then we can call it as a lossy medium. We'll call it as a lossy medium. If sigma by omega epsilon, if it is very much greater than 1, then we can call it as a high loss medium. High loss medium. Losses are more, na? Then we can call it as a high loss medium. And if sigma by omega epsilon, if it is very much less than 1, then we can call it as a low loss medium. Then we'll call it as what? Tell me now. Low loss medium. Based upon this sigma by omega epsilon, we can comment about the losses. High loss medium is nothing but good conductor. That is, call it as what? Tell me now. Good conductors. And low loss medium is nothing but good dielectrics. Okay. And if we observe here, JC is what? Tell me now. Conduction current. JD is a displacement current. And what is angle between these two? Tell me now. JC and JD is a angle between the JC and JD is how much? 90 degrees. Angle between JC and JD is how much? 90 degrees. So from this, what I can say now here? What we can say now here? Displacement current leads the conduction current by 90 degrees. What we can say now here? Displacement current leads the conduction current by 90 degrees. Displacement current leads the conduction current by how much? 90 degrees. Where you can see this phenomena? For capacitor you will find this phenomena. So you might be seeing this as, for capacitor you might be seeing this thing. For capacitor, so you can find for capacitor, this is current, that is IC leads VC by 90 degrees, isn't it? IC leads VC by 90 degrees. So this things. The same concept, that is, as we know, the current passing through capacitor is what type of current? Is a displacement current. So that's why the current leads the voltage by 90 degrees. Right? Next one. Next, now let's talk about the wave propagation through the good conductors. Abhi tak we have seen the wave propagation through where we have seen free space and ideal dielectrics we have discussed. Now we'll talk about the wave propagation through the good conductors. What are the good conductors means? What? Tell me. Good conductors means what? Tell me now. High loss medium. Good conductors means what? High loss medium. High loss medium, the conditions are what we have seen. High loss medium, the conditions are what? Good conductors mean that is nothing but high loss medium. High loss medium means the condition is what I know, sigma by omega epsilon, which is greater than 1. Based upon this relation, we need to generalize, approximate it. So from this, what I can say now here, and what is gamma, you tell me? Gamma is alpha plus j beta, which is equal to what we can say, that is j omega mu into what, tell me now? Sigma plus j omega epsilon. Here sigma by omega epsilon is very high, so that's why what I am doing is I am taking it as a, in this whole thing, j omega mu into what, tell me now? We am taking it as a j omega epsilon. I am taking common. Epsilon we have taken common. So then this will becomes what, tell me? This second whole term common. Then it will come it as 1 plus sigma by j omega epsilon. Alpha plus j beta, which is equal to what we have, j omega into square root of mu epsilon into what, tell me now? 1 j to numerator minus j by omega epsilon power 1 by 2. So the sigma by omega epsilon is very small. Sigma by omega epsilon. No, it is very high now, not very small. It is very small, very high value. So sorry, it is very high value now. So that means we cannot do this approximation. We cannot. Nahi chalega. This is very high now. Sorry, we have mistaken this thing here. I thought it is less value. It is very high. We cannot do this approximation. Okay, it's a mistake. Right. So sigma value. So that means here sigma by omega epsilon is very high. That means what we can say now, sigma is very much greater than omega epsilon now. Sigma is very much greater than omega epsilon. So that's why this term, which we are neglecting, this term, neglecting this term. So then what I will get now here? So we have only the square root of what, tell me now? That is j omega mu sigma is there now. J means 90 degrees. So this means what we can say, square root of mu, that is omega mu sigma into e power j pi by 2 will come it as pi by 4. So then will come to be a, what, tell me now here, alpha plus j beta, which is equal to what, tell me now, square root of, so that is omega mu sigma into what, tell me now here, 1 by root 2 plus j 1 by root 2. Okay. Then from this, what I'll get, you see this thing, alpha plus j beta, which is equal to square root of omega mu sigma by 2 plus j square root of omega mu sigma by 2, isn't it? we'll get like this. And so this alpha, from this we can get this alpha, betas are equal na, alpha equal to beta equal to how much? Square root of omega mu sigma. Omega mu sigma by 2. This is alpha equal to beta. Right? So in case of a good conductors, high loss, medium, alpha, betas are equal. Next. Now let us see the intrinsic impedance also. That is eta, which is given as what tell we now E by H, and which is equal to what tell we now square root of j omega mu by, tell me now here, sigma plus j omega epsilon. Then eta, which is equal to what tell me E by H, which is equal to square root of we j, yeah, here also. So here sigma is very much greater than omega epsilon na. So this term we are neglecting here. Neglect. J omega mu by what tell me now sigma. So that is eta, which is equal to E by H, and which is equal to this term square root of omega mu by sigma into e power j pi by 4, 45 degrees. Then eta, which is equal to, that is E by H, and which we can say this as square root of omega mu by sigma into what will be now 1 by root 2 plus j 1 by root 2. Right. You can see this thing here from this eta value, this eta, which we can write it as square root of omega mu by 2 sigma plus j square root of omega mu by 2 sigma. This, which we can say this as what terminal here, Rs plus j xs, where Rs is called as a sheet resistance, xs is called as the sheet reactance. These are called it as, Rs is called as sheet resistance. Sheet or surface, sheet resistance. Rs, and this xs is called as a sheet reactance. Xs is called as sheet reactance or surface reactance, we used to call. So you can see now here the intrinsic impedance of a high loss medium is, it has a real term as well as the imaginary term also. It has a real as well as imaginary. So from this, which we can see it as what, tell me now, the what we can say now here, the intrinsic impedance of a high loss medium is a complex. Intrinsic impedance of high loss medium is a complex with what nature? Inductive nature. We have a so plus na, so that's why reactance is positive, that's why it is a we can call it as a inductive nature. So what we can say, the intrinsic impedance intrinsic impedance. Intrinsic impedance of a high loss medium. High loss medium is complex. Complex with inductive nature. Okay. Next one. Wave propagation, the low loss dielectric. Low loss dielectric means good dielectrics. Good dielectrics. So in this case, you can see now that means the condition is what tell me sigma by omega epsilon value very much less than 1. So then this gamma which is equal to alpha plus j beta. Gamma alpha plus j beta, that is given as square root of j omega mu into sigma plus j omega epsilon. Sigma by omega epsilon is very much less than 1. Then what happens, you tell me? Then I'm taking it as a j omega epsilon I am taken outside. J omega epsilon taken outside, then it will becomes what, tell me? 1 plus sigma by j omega epsilon. Then it is alpha plus j beta, which is equal to what, tell me now? J omega square root of mu epsilon into 1 minus j sigma by omega epsilon power 1 by 2. So this term is very small, since it is 1 plus x whole power n, we can approximate as 1 plus nx na. Higher order powers are neglected since sigma by omega epsilon is very small. If the x is very much less than 1. Binomial approximation, so that is alpha plus j beta, which is equal to what, tell me now? J omega into square root of mu naught mu epsilon into what I will get, you tell me now here? 1 minus j by what we can say now here? 2 omega epsilon. Okay, now if we multiply that, so we'll come it as what, tell me now? Alpha plus j beta, which is equal to j omega square root of mu epsilon. J into j square is a plus 1. So I will come it as omega will get cancelled. That is 1 by 2. Okay. 1 by 2 into omega cancelled. Sigma is there. And square root of what will come here? Mu by epsilon. Check this thing. Yes. Now here you can see the real part is alpha. Alpha is what, tell me now? Sigma by 2 into square root of mu by epsilon. And the beta is the phase constant, that is omega square root of mu epsilon. Okay. This thing. Now in this case also we can able to find the phase velocity, all the terms we can do it now. and we can find the phase velocity Vp, which is equal to omega by beta, and that equal to what? Tell me now. Omega by beta, that is omega square root of mu epsilon, which is equal to what? Tell me now. 1 by square root of mu epsilon. After that, we'll get the Vg. So you can see Vp independent of frequency, so it is Vg equal to Vp only. Vg and Vp both values are equal. And the intrinsic impedance we can find, that is eta, which is equal to E by H, and which is equal to square root of j omega mu by sigma plus j omega epsilon. So which is equal to what? Tell me now here. E by H, and which is equal to and square root of so what I can do here, so j omega mu by, will take out the j omega epsilon common, so this is what I know 1 plus yes sigma by j omega epsilon. So then eta, which will come to be a what? Tell me now here. E by H, and which is equal to square root of mu by epsilon into 1 minus j 1 minus j sigma by epsilon power minus 1 by 2. So how much this value will come? Then this eta will come to be a square root of mu by epsilon into what? Tell me now. 1 plus j sigma by, that is 2 omega epsilon. Okay. Sigma by omega epsilon is very small if you neglect it now here. So then eta will come to be a, that is square root of mu by epsilon will come. This value approximately equal to how much? You can say now 125 ohms in case of a lossless dielectrics. Okay. Next. Got it, all of you? Next. Yeah, you tell me now here, phase difference between E and H in a high loss medium. High loss medium means what? Good conductor. High loss medium phase difference. Basically, phase difference between electric field and magnetic field is nothing but the phase angle of intrinsic impedance only. That is Z is equal to Z, or we can say eta, we can say. That is, here we use eta, which is equal to what? Tell me now. E by H, and that is equal to, we have seen now, in case of high loss medium, the impedance is what? Tell me now. Square root of omega mu sigma into e power j 45 degrees. So how much the phase difference? You tell me now. Phi value, which is equal to 45 degrees. Next. Yeah. Next, see this problem. A material has sigma value given the frequency at which the conduction current equal to displacement current. The frequency at which a conduction current equal to displacement current, that frequency is called as a transition frequency. Transition frequency. The transition frequency, that is Ft, which is equal to what tell me now? Sigma by 2 pi epsilon. Sigma value 10 power minus 2 by 2 pi epsilon equal to 3 epsilon naught is what tell me now? 1 by 36 pi into 10 power minus 9. So you can simplify this thing Ft value. How much will come? Yeah, tell me how much will come this one? Do simplify them. So this pi will get cancelled now here. 6 now here, this is 6. Will go to numerator, so that is 6 into 10 power 7 now. This is Hz. Means we can say now 60 megahertz. Right. The electric field of a plane electromagnetic wave is given as like this. The corresponding magnetic field is given by. So they give an electric field and they ask him to find this magnetic field, they ask him to find. Right. So you can see this thing here. They are asking B, they are asking, right. So that means as E by H is equal to what tell you now? Eta. And E by B equal to C, velocity. E by B equal to C. So B is equal to, and so that means E by B, which is equal to C, velocity of light, which is given as, so that is this is mu naught mu epsilon, free space medium mentioned, mu epsilon in case of a B. So that is B is equal to what you will get to tell me now here, that is E by, that is square root of mu epsilon. Yes, we know this omega is equal to beta. We can write now beta equal to, yeah, beta equal to omega into square root of mu epsilon, right? So mu epsilon 1 by, or we can say mu epsilon is how much? Square root of mu epsilon, which is nothing but beta by omega. That means what tell me now here? This is k by omega. So will come to be a, this is E by, this is what tell me now? K something is different is going to come. What happened? Right, so this E given now. Okay, so E, which is equal to what tell me now here? E naught into, that is cos of omega t plus kz into I cap means x direction. We'll find the h now. H is equal to what? Tell me now. E naught by eta. Eta given as E naught by eta, we can say. Medium, type of medium not mentioned now. So this is, we can write eta simply, and cos of what I can say, omega t plus kz into, this is k cross e minus k cap cross I cap. Then h value come to be a what? Tell me. That is E naught by eta into what? Tell me now here. This is cos of omega t plus kz into k cross I means will come k cross I. This is minus j cap. Minus j cap. Then h value which is equal to what? Tell me now here. Minus E naught by eta into, that is cos of omega t plus kz into what? Tell me now here. J cap. Okay. This is E, but we need to get the B now. B is equal to mu h. So this means B is equal to mu, that is minus mu, this is E naught by eta, this is cos of omega t plus kz into j cap. Okay, next, but options are not given here, you see. Now we need to, so here mu eta, we should convert eta in terms of omega. Okay, so yeah, what is the beta value? Beta is equal to omega into square root of mu epsilon. Eta, beta means it is a k here. K omega square root of mu epsilon. Okay. Next, what is eta value? Okay. Basically, gamma beta equal to, that is omega square root of mu epsilon, and this eta equal to what? Tell me now. Basically, that is square root of mu j omega mu epsilon, that is what we can say, square root of mu by epsilon. Here this is a k. So if we take the if I take the ratio between these two, k by eta, see what I will get now, k by eta. If I have taken the ratio, what will get? You tell me now. Omega into epsilon will come. No, if you multiply them, if we multiply this thing here, k into eta, if we multiply, omega into mu will come. So this value, yeah, eta by mu. So this is mu by eta, that is k by omega, which is equal to mu by eta, isn't it? So that means beta value will come to be a minus. So this is E naught by k omega, that is cos of omega t plus kz into j cap. But options are not in this form now. Omega and k they given ulta mein hai na, isn't it? So that means not in this form, some other form we need to get it. Okay, not in this form. we need to modify करना पड़ेगा इसको. So let's see this thing, what I can do. So here we got this B value is what, tell me now first of all, here up to here. That is minus mu E naught by eta into cos of omega t plus kz into, so this is ay cap. Okay, next, and what is this thing here? So eta equal to square root of mu by epsilon. Okay, beta equal to omega square root of mu epsilon. Right, we need to get the relations here for this. We need in terms of omega, we need now here. If I have multiplied these two, tell me what I'll get. Eta into beta, tell me what I'll get. That is omega into mu will come now. So that is eta equal to omega mu by beta. So that means eta, which is equal to omega mu by beta, is given as k given the problem. So this means B is equal to what, tell me now, minus mu E naught by eta equal to omega mu by k into what, tell me now, cos of omega t plus kz into ay. We'll go to numerator, so that is beta, yes, mu will get cancelled, minus k E naught by omega into cos of omega t plus kz into ay. Why I got this much, yeah? Yeah, okay, so directly here only we can simplify, na? Sorry, unnecessarily we did this thing here. E by B, which is nothing but Vp. Vp is equal to omega by beta. Beta equal to k given na. So that means B is equal to what, I mean, k E by B, sorry, omega. Omega here only will come now. So this means B is equal to k E naught by omega. Yeah, unnecessarily we did this much. Achha. Unnecessarily simplification we did. Here only we'll get this thing, no? Chalo. Tell me now. The loss tangent of a medium is root 3. They are asking to find the phase difference between electric and magnetic fields. Yeah, the loss tangent that is given as tan theta, which is given as root 3. That means theta given as how much, you tell me now here, 60 degrees na. So we need to find what is the phase difference between electric and magnetic field. The relation between the loss tangent and the phase difference is theta is equal to 2 theta of eta. So that is theta of eta, which is equal to 60 by 2, which is equal to how much now? 30 degrees. This is a 30 degrees. So that means the angle between electric and magnetic field is how much? 30 degrees. Next, for a given medium, characteristic impedance is given as this much. Characteristic impedance eta given as, that is 15 at an angle of 30 degrees. So the given theta of eta given as how much now? 30 degrees. We need to get the loss tangent. So theta value how much? Theta equal to 2 theta of eta. So from this, how much the theta value? 60 degrees. So loss tangent means what? Tell me. Loss tangent means which is equal to tan theta. So which is equal to tan 60. And which is how much you tell me now? Root 3. Uh-huh. Okay, fine. Yeah. Okay, that's it for today's session. Next class we'll discuss about the skin depth and the pointing vector हम discuss करेगा. Pointing theorem we'll discuss in the tomorrow class. Okay, fine. See you.